All right, welcome back. Today we are going to finish up section 4.4. We are working on factoring quadratic expressions. Today our focus will be on these special ones. So we have something called the difference of two squares. And what happens is we have a perfect square and we're subtracting another perfect square. So we have a squared minus b squared. And when we factor that, it breaks down into two factors that are almost identical except for opposite signs. Those are called conjugates. So in our first example here, x squared minus 64, we can split our x squared up into x and x, and we can split our 64 into 8 and 8. Now to get a negative 64, one of those would have to be negative. So if we look at our factors, we have an x plus 8 and an x minus 8. If we were to FOIL that back out, x times x would be x squared, outsides would get us a negative 8x, and insides would get us a positive 8x. And our last term would then be the negative 64. And those middle pieces are going to drop out to leave us with x squared minus 64. So a difference of two squares is going to factor into two binomial factors that are exactly the same except for their the sign in between your numbers. All right, our second example, we have 9x squared minus 4. We can split the 9x squared into 3x and 3x. Now we could also use 9x and 1x. And for the negative 4, we have other options that get us a negative 4. But if we notice that it is a perfect square minus another perfect square, and there's no middle term, then we should try the ones that match. So 3x and 3x gets us our 9x squared. A positive 2 and a negative 2 will get us the negative 4. And if we check insides and outsides, we end up with opposites. So they're going to add up to 0. No middle term. Now the best thing to do for recognizing these is to know your perfect squares. So we have our first 10 perfect squares listed here. So looking at our next example, x squared minus 100. X squared is a perfect square, and so is 100. Its root is 10. So if we think of splitting this x squared, we'd get an x in each one. We're going to split our 100, our negative 100, into a positive 10 and a negative 10. And then checking again, insides and outsides will cancel each other out. 16x squared minus 49. Checking to see, do we have perfect squares? 16 is on our list. Its root is 4. So we're going to think of splitting this into 4x and 4x. 49 is also on our list. We get a 7 for its root. So we need a negative 7 and a positive 7. All right, go ahead and pause the video and try the next two. All right, let's check your answers. X squared minus 36, you should have factored into x plus 6 and x minus 6. And 25x squared minus 81 would break down into 5x and positive 9 and negative 9. Now, how are these next two different? Notice that we still have some perfect squares. 9 is perfect, 25 is perfect, and that x to the 6th is also perfect. If we think about splitting it up into two equal pieces, we can think of making that 9x to the 6th into 3x cubes. We still end up with a 9, 3 times 3, and x cubed times x cubed would get us x to the 6th. So we are still splitting it up into two equal pieces. To get the negative 25, we need a positive 5 and a negative 5. Now, our next one here is a little bit different in that we have basically reversed our two terms. We have our constant first, but it is still a perfect square. 81 would get us 9 and 9. The x to the 4th, we are going to split into two equal parts. So we're going to have 4 x's here. We would have to put 2 in each one. So we have an x squared in each one. And again, to get the middle term to disappear and have a minus sign there, we need one positive and one negative. Now, one thing that's special about this one is that this is also a difference of two squares. So we can actually break this down a little further. This first piece cannot be broken down. It is the sum. We're adding two squares, and we don't have a pattern for breaking that down. It's not possible. But a difference of two squares can be broken down like we've been doing. The 9 we would split into 3 times 3, and the x squared we would break up into x and x. To get no middle term and a minus sign here, we would need one positive and one negative. So that's the special pattern for today, the difference of two squares. Our last 4 examples, we are just reviewing all of the different factoring techniques that we've had so far. So our first one, remember, looking for a GCF, that common factor, greatest common factor, is the first thing you should always do. So in this first example, we could pull out a 3 and an n. If we divide both terms by 3n, we have a 2n from the first term, and we have a positive 3 from the second term. And there's nothing more we can do to factor that. We don't have any more squared terms to break down. Our next example, we have a 4x cubed and a 25x. They both have a common x, so let's factor that out. We'd have 4x squared minus 25 left. And that is one of our special patterns from today. It is a difference of two squares. The 4x squared we would split into 2x and 2x. And the negative 25 we would split into one positive 5 and one negative 5. Notice that the GCF is part of your final answer. All right. Our next question, again, looking at whether we have a GCF. They don't all have x's. There's no x on our last term here. However, we could divide a 4 out of everything. If we do that, we have x squared plus 5x minus 14. Now that's one of our basic trinomials. Our first term here is an x squared. So let's try splitting it up into x and x. It's not a difference of squares. We have a middle term, and our constant, our negative 14, is not perfect. But we can look at our factoring techniques from earlier and look at ways to get a negative 14. We could have negative 1 and positive 14, or the reverse pair. We can have negative 2 and positive 7, or the reverse pair. And we want two numbers that are going to add up to be that 5. So we would want to pick this pair. We need a negative 2 and a positive 7. Once again, notice that the GCF is part of my final answer. All right, go ahead and pause the recording and try this last question. Then turn it back on to check your work. All right, you should have pulled out a 3x as your GCF. That leaves us with 5x squared plus 11x plus 2. Once again, we have a trinomial. This time we do need to split our 5x squared into a 5x and an x. To get a 2, we are just looking at the pair 1 and 2, but we need to place them to create an 11 in the middle. So if you put the 2 on the outside here, when you do outsides, you would get 10x, and insides you would get 1x, and that's going to get us the 11x in the middle. All right, so you have a Delta Math assignment to work on this topic.